For the second part of this lecture, we're going to continue discussing cloud computing. The National Institute of Standards and Technology defines cloud computing as a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimum management effort. This cloud model provides availability and is composed of 5 essential characteristics, 3 service models, and 4 deployment models. This figure here on this slide shows the relationships between the various models and characteristics. There are 5 main essential characteristics of cloud computing. The first one is broad network access, referring that capabilities are available over the network and can be accessed through standard mechanisms. The second one is rapid elasticity. It indicates that cloud computing provides the ability to expand and reduce resources according to specific service requirements. The third one is measured service. It means that cloud systems automatically control and optimize resource use by leveraging a metering capability at some level of abstraction appropriate to the type of service. The fourth one is on-demand self-service. It indicates that a consumer can unilaterally provision computing capabilities as needed without requiring human interaction with each of the service provider. The final characteristic is resource pooling. It implies that the provider's computing resources are pooled to serve multiple consumers using a multi-tenant model, with different physical and virtual resources dynamically assigned and reassigned according to consumer demand. The National Institute of Standards and Technology defines 3 service models which are viewed as nested service alternatives. The first one is software as service. In this model, the consumer can use the provider's application running on a cloud infrastructure. The applications are accessible from various client devices through a thin client interface, such as a web browser. The main benefit is that software as a service eliminates the complexity of software installation, maintenance, upgrades, and patches. The second model is platform as service. Under this model, the consumer can deploy onto the cloud infrastructure consumer-created or acquired softwares using programming languages and tools supported by the provider. Platform as service often provides middleware-style services such as databases and component services for use by applications. In fact, it is an operating system in the cloud. The final model is infrastructure as service. Under this model, the consumer can provision processing, storage, networks, and other fundamental computing resources. The consumer can also deploy and run arbitrary software, including operating systems and applications. Infrastructure as service enables consumers to combine basic computing services such as number crunching and data storage to build highly adaptable computer systems. In addition, the National Institute of Standards and Technology defines 4 deployment models. The first one is public cloud. The cloud infrastructure is made available to the general public or a large industry group. The infrastructure is generally owned by an organization selling cloud services, and the cloud provider is responsible for cloud infrastructure, the control of data, and operations within the cloud. The second model is private cloud. In this model, the cloud infrastructure is operated solely for a single organization. It is either managed by the organization or a third party, and the cloud provider is responsible only for the infrastructure, not for the control. Community cloud is the third model. In this model, the cloud infrastructure is shared by several organizations and supports a specific community with shared concerns such as missions and policies. The infrastructure is managed by the organizations or a third party. The final model is a hybrid cloud. The cloud infrastructure is a composite of 2 or more clouds, in other words, private, community, or public. These 2 or more clouds remain unique entities, but are bound together by standardized or proprietary technology that enables the portability of data and applications. The special publication Cloud Computing Reference Architecture shows a generic high-level conceptual model for discussing the requirements, structures, and operations of cloud computing. The objectives of the architecture are, first, to illustrate and understand various cloud services in the context of an overall cloud computing conceptual model. Second, to provide a technical reference for consumers to understand, discuss, categorize, and compare cloud services. And third, to facilitate the analysis of candidate standards for security, interoperability, portability, and reference implementations. The architecture defines 5 major actors in terms of their roles and responsibilities. Cloud consumer is a person or organization that uses the services from cloud providers. Cloud providers refers to an organization or entity responsible for making the service available to the interested parties. Cloud auditor is a party that conducts independent assessment of cloud services, operations, performance, and security of the cloud implementation. Cloud broker refers to an entity that manages cloud services and negotiates relationships between the cloud providers and cloud consumers. And finally, cloud carrier is an intermediary that provides connectivity and transport of cloud services from the cloud providers to the cloud consumers. To summarize, a cloud provider or cloud service provider provides one or more cloud services to meet the IT and business requirements of the cloud consumers. For each of these 3 service models, the cloud provider provides storage and processing facilities needed to support the service model, together with the cloud interface for the cloud service consumers. For software as service, the cloud provider deploys, configures, maintains, and updates the operation of the software applications on a cloud infrastructure. The consumers of software as service are organizations that provide their members to access the software applications. For platform as service, the cloud provider manages the computing infrastructure for the platform and runs the cloud software that provides the components of the platform. Cloud consumers of platform as service use the tools and resources provided by the cloud providers to develop, test, deploy, and manage the applications hosted in the cloud environment. Finally, for infrastructure as service, the cloud provider acquires the physical computing resources underlying the service, including the servers, networks, storage, and hosting infrastructure. Cloud consumers of infrastructure as service, in turn, uses the computer resources for fundamental computing needs. There are several key issues that need to be addressed when an organization moves data and applications into the cloud. Placing data in the cloud introduces new risks that must be addressed, particularly the confidentiality and privacy of data. Also, placing data and services in the cloud increases concerns about data breaches, but security is not under direct control of the consumer anymore. In addition, organizations and their legal counsel can be obligated to keep records needed for legal discovery. However, these records are not under direct organizational control. The organization no longer has the record in the same way as it formerly did. To perform effective risk assessment, the consumer must have considerable information about whether the cloud service provider has effective security policies and controls. In some cases, it may be difficult to get all that information. Plans are needed to deal with the suspension or termination of cloud service. In case of suspension or termination, the cloud customer needs to have capability to move data to a different cloud service provider. Finally, there are many legal risks and obligations that must be clarified and documented. The use of cloud services and resources introduces a novel set of threats to enterprise cybersecurity. First of all, regardless of the level of service, it is difficult to define precisely the security responsibilities of the customer and those of the cloud service providers. If there is any ambiguity, this complicates the risk assessment, security control design, and incident response. Second, the migration of part of the enterprise IT resources to the cloud infrastructure gives partial management control to the cloud service provider. The degree of loss of governance depends on the cloud service model. In any case, the enterprise no longer has complete governance and control over the IT operations. Third, it is sometimes difficult for the cloud service user to assess the provider's trust level due to the black box feature of the cloud service. Furthermore, cloud service users are generally unable to evaluate the security implementation level achieved by the provider. This in turn makes it difficult for the customer to perform a realistic risk assessment. Fourth, a consequence of the loss of governance could be the lack of freedom in terms of how to replace one cloud provider with another. Fifth, as most resource deliveries are through remote connections, unprotected application programming interfaces are among the easiest attack vectors. Attack methods such as phishing, fraud, and exploitation of software vulnerabilities pose significant threats. Sixth, the cloud service user may have difficulty in assessing and monitoring asset management by the cloud service provider. Furthermore, the cloud service users are also likely to have important concerns about the exposure of data to foreign governments and compliance with privacy laws. Finally, loss of an encryption key or privileged access code brings serious problems to cloud service users. Accordingly, the lack of cryptographic management information leads to sensitive damages such as data loss and unexpected leakage to the outside. As a result, when an organization moves to the cloud service, it is useful to have a detailed questionnaire for performing risk evaluation for the cloud service. The Information Security Council develops a template to be used for this purpose. When using a public cloud or an outsourced private cloud, an organization is faced with a complex environment in which to evaluate threats, vulnerabilities, and risks. Much of this challenge relates to the adequacy of the security controls provided by the cloud provider. Therefore, an organization must exercise due diligence when selecting and moving functions and resources to the cloud. The National Institute of Standards and Technology Special Publication provides a list of best practices for outsourcing a cloud service provider. From the point of view of the overall mission and objectives of an enterprise, and in particular from the point of view of security, an essential aspect of using outsourced cloud service is a formal cloud service agreement. The Cloud Standards Customer Council provides the following as the typical major components of a cloud service agreement, and the list is listed here on this slide.